Good to see you, curious minds. That Claude Opus 4.8 just shipped, and the headline feature isn't a bigger benchmark number. It's that the model actively works to catch its own mistakes before they reach you. Anthropic calls it effort dial control, and it fundamentally changes what a model can do when it's allowed to second-guess itself. Let me walk you through what's actually new, what it means for your workflow, and why the architecture changes matter more than the benchmarks. First, let's ground ourselves. This isn't a brand new model family. Opus 4.8 builds on the same foundation as Opus 4.7. Same base architecture, same pre-training. What changed is the fine-tuning, the system prompt engineering, and the inference time compute strategy. Here's the key insight. Anthropic didn't just make the model bigger or train it on more data. They taught it to think about how hard a problem is before committing to an answer. That's the effort dial. The model can dynamically allocate more or less compute depending on the complexity of the task. This is a fundamentally different approach from the bigger is better philosophy that's dominated LLM development. Instead of scaling parameters, Anthropic scaled reasoning. They taught the model to pause, evaluate, and self-correct, which is something humans do naturally, but language models have never been very good at. On the benchmarks, Opus 4.8 scores 69.2 on SWE-Bench Pro, 5 points clear of Minimax M3's 59. On Terminal Bench 2.1, 74.6. On MCP Atlas, 77.8. And on OSWorld, verified, 83.4. A full 13 points ahead of M3. But the real story isn't the headliners. It's the reliability improvements. Let me explain what catches its own mistakes actually means in technical terms, because this is the part that matters most for production use. Traditional language models generate tokens sequentially. Once a token is emitted, it's locked in. If the model makes an error early in reasoning, that error propagates through the rest of the generation. There's no mechanism to say, wait, let me reconsider. Opus 4.8 introduces a structured self-evaluation loop. Before finalizing a response, particularly on multi-step reasoning, code generation, or complex analysis, the model generates an internal assessment of its own output. It checks for logical consistency, factual accuracy, and completeness. Think of it like a draftsman who draws a sketch, then reviews it against the requirements before handing it to you. The model doesn't just produce. It produces, evaluates, and then decides whether to commit or revise. This manifests in 3 concrete ways. First, code generation. Opus 4.8 is 4 times less likely to introduce flaws when transforming or refactoring existing code compared to earlier models. 4 times! That's not a marginal improvement. That's a different reliability class. Think about what that means in practice. If you're migrating a legacy codebase from Python 2 to Python 3, or refactoring a monolithic application into microservices, or updating dependencies across a large project, the model is now 4 times less likely to introduce subtle bugs during those transformations. That's the difference between a refactoring task that takes 1 review cycle versus one that takes 4. Second, multi-step reasoning. The model explicitly breaks complex problems into sub-problems, solves each one, and then verifies the solutions are consistent before composing the final answer. If it catches an inconsistency, it retries the problematic step, rather than propagating the error. This is particularly important for tasks like data analysis, where an error in an early step can cascade through the entire analysis. The self-correction loop catches these cascading errors before they reach your final output. Third, tool use reliability. When using tools, web search, code execution, file operations, Opus 4.8 validates tool outputs before incorporating them into its reasoning. If a web search returns unexpected results, it'll flag the discrepancy rather than blindly trusting the output. The second major feature is something Anthropic calls dynamic workflows. And this one is subtle but powerful. In previous Claude models, complex tasks required you to manually architect the solution, break it into subtasks, manage state, handle branching logic. The model was a building block, not a coordinator. Opus 4.8 can now autonomously decide when to spin up parallel subagents. It analyzes the task, identifies which parts can be solved independently, and launches parallel reasoning threads, all without you orchestrating the workflow. Imagine you give it a research task. Analyze these 5 competing products, compare their architectures, and produce a recommendation. Instead of working through them sequentially, Opus 4.8 can recognize that the 5 analyses are independent and spin up parallel subagents for each one. It collects the results, synthesizes them, and delivers the final recommendation. The key insight here is that the model isn't just doing the work. It's deciding how to organize the work. That's a fundamental shift from smart autocomplete to smart coordinator. And this has practical implications beyond just convenience. When you're paying per token, parallel execution means you're using more tokens simultaneously, but you're also getting results faster. For time-sensitive tasks, the speed improvement often justifies the additional token cost. And for complex tasks that would otherwise require multiple back-and-forth exchanges with the model, dynamic workflows can actually reduce total token usage by eliminating the coordination overhead. Now, the feature that I think will change daily workflows the most, the effort dial. Previous Claude models had a simple toggle, fast mode or extended thinking. Binary, either the model thought hard about everything or it thought fast about everything. Opus 4.8 introduces a continuous dial. You can tell the model exactly how much effort to allocate for a given task. Low effort for quick factual questions. Medium effort for standard analysis. High effort for complex multi-step reasoning. And here's the practical impact. When operating in fast mode, Opus 4.8 is 3 times cheaper than the previous fast mode. $2.50 per million input tokens. $12.50 per million output tokens. Compare that to the full effort pricing of $5 input, $25 output. So you can run your quick queries at a third of the cost and only pay premium pricing for the tasks that actually need deep reasoning. That's not just convenient. It makes Claude economically viable for high-volume workflows where cost was previously prohibitive. Think about the use cases this unlocks. Customer support chatbots that need frontier intelligence but can't justify $5 per query costs. Content generation pipelines that process thousands of articles daily. Data analysis workflows that run continuously. All of these become economically viable when you can dial down the effort for routine tasks and only pay premium for complex ones. Let me put these numbers in context, because benchmark scores without context are just noise. SWE-Bench Pro at 69.2. That's the gold standard for real-world software engineering. The benchmark uses actual GitHub issues from popular Python repositories, not synthetic problems. Opus 4.8 resolves nearly 7 out of 10 issues autonomously. For comparison, most production coding assistants handle 3 to 4 out of 10. Terminal Bench 2.1 at 74.6. This tests the model's ability to execute multi-step terminal commands accurately. System administration, DevOps tasks, deployment scripts. 3/4 accuracy on the hardest terminal tasks is a meaningful threshold for production use. MCP Atlas at 77.8. This tests the Model Context Protocol, which is how Claude integrates with external tools and APIs. Higher scores mean more reliable tool orchestration. And OSWorld verified at 83.4. This is the computer use benchmark. The model interacts with the real desktop environment, opening applications, navigating file systems, filling out forms. 83% accuracy on real computer tasks. That's the number that should make you pay attention. Now, here's the important caveat. These benchmarks are on specific, well-defined tasks. Real-world software engineering is messier. You're dealing with ambiguous requirements, incomplete context, legacy code with undocumented behavior, and team dynamics that no benchmark can capture. The benchmarks tell you the model's capability ceiling. Your mileage will vary based on how well you prompt it and how complex your actual workflow is. That said, the direction is clear. Each generation of models gets meaningfully better at real-world tasks, and Opus 4.8 represents a genuine step forward in reliability, which is what matters most for production use. So who benefits most from Opus 4.8? First, software teams using Claude Code or Cursor. The 4 times reduction in code flaws during refactoring is enormous. If you're doing large-scale code migrations, legacy system updates, or complex refactoring, Opus 4.8 will save you significant debugging time. Second, anyone doing multi-step research. The dynamic workflows feature means you can give Claude a broad research question and trust it to organize the investigation autonomously. No more hand-holding. Third, high-volume API users. The fast mode pricing at $250 input makes Claude viable for workflows where you previously used cheaper models because of cost constraints. You can now run your quick queries through a frontier model at economy pricing. Fourth, teams with strict reliability requirements. The self-correction loop means fewer silent failures. If you're building production systems that depend on LLM outputs, content generation, data processing analysis pipelines, the reduction in error rates compounds significantly at scale. And here's the underappreciated benefit: consistency. When a model catches its own mistakes, you get more predictable output quality. That means fewer edge cases, fewer customer complaints, fewer manual reviews. The operational overhead of managing LLM-powered systems drops when the model itself is more reliable. Because I believe in intellectual honesty, here's what Opus 4.8 isn't. It's not a step change in raw capability. The benchmark's improved, but incrementally. If you were expecting a GPT, 4 to GPT, 5-level jump, this isn't it. It's more like GPT, 4, 0 to GPT, 4, 5. Meaningful, but evolutionary. The effort dial adds latency. High effort mode takes noticeably longer than previous extended thinking. You're trading time for accuracy, and for some use cases, the latency isn't worth it. If you're building a real-time chatbot, you probably want fast mode. If you're doing code review or research, the latency is justified, and the pricing, while improved in fast mode, is still premium. $5 input, $25 output at full effort is the same as Opus 4.7. The cost improvement only applies when you dial down the effort. But, and this is important, for the tasks where self-correction and reliability actually matter, the latency and cost are justified. You're paying for the model to check its own work. That has real value. Here's the bottom line. Curious minds. Opus 4.8 isn't the most exciting Claude release in terms of headline benchmarks, but it might be the most important one for production use. Self-correction that actually catches real errors. Dynamic workflows that let the model orchestrate its own work. An effort dial that makes frontier intelligence economically accessible for routine tasks. These aren't flashy features. They're the kind of boring, reliable improvements that make you stop reaching for other models in your daily workflow. And in my experience, that's exactly what drives long-term adoption. Not the demo that wows you once, but the tool that reliably works every day. Link in description for the full technical breakdown. And I'll see you in the next one. Off you go! But don't wander too far!